It's okay, bro.
Yes.
Recall that the general form of the equation, the general form of the equation of a circle is x squared plus y squared plus 2gx plus 2fy plus c is equals to 0. This is the general form of the equation of a circle. Now, what do you observe from here? That the general form of this equation of a circle is a function of two variables. It is a function of two variables. Since this general form of the equation, equation of a circle is a function. It's a function of two variables. Then we can write. That f of xy is equals to x squared. F of xy is equals to x squared plus y squared plus 2gx plus 2fy plus c. In other words, this circle is a function of two variables. And the mathematical way of expressing function of two variables is to say f of xy. So this is what we have. Now, if a point P whose coordinates are x1, y1 lies on this circle, lies on this circle, then we can write that f of x1, y1 is equal to x1 is equals to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, and it will be equal to 0. So, what am I saying? If we substitute the coordinates of point, the coordinate of a point, if we substitute x1, y1 in the general form of the equation of a circle, it is going to give us 0. And that shows that that point x1, y1 lies on the circle. That point. So, meaning that we have something like this. That is the center. So, if that point is denoted as P, point P, x1, y1, lies on the circle. That is what I'm saying. This point P, x1, y1, lies on the circumference of the circle. In other words, i.e., f of x1, y1 is equal to 0.
condition. The condition for that point P, whose coordinates are x1, y1, to lie on the circumference of the circle is that f of x1, y1 must be equal to 0. In other words, if we substitute that point x1, y1 on the general form of equation of the circle, it must be equal to 0. So that is the conditions for that point to lie on the same the circumference of the circle. Now, if, comma, on the other hand, if on the other hand, point Q, x2, y2 lies inside the circle, then f of x2, comma, y2 will be less than 0, i.e. x2 square plus y2 square plus 2gx2 plus 2fy2 plus c is equals, no, is less than, will be less than 0. So this is the condition for that point Q, whose coordinates are x2, y2, to lie inside the circle. Which is, you have something like this. So that point Q is inside point Q, whose coordinates are x2, y2, lies inside the circle. That is the point. That's what I'm saying. Now the third condition. The third condition is for a given point. It's for a given point to lie outside the circle. For a given point to lie outside the circle. For a given point to lie outside the circle. If a given point T, whose coordinates are x3, y3, lies outside a circle, then f of x3, y3 is greater than 0. So in that case, the point lies outside the circle, point T, x3, y3. So you can see that point T is outside the circle. So this is the condition. In other words, x3 square plus y3 square plus 2g x3 plus 2f y3 plus c is greater than 0. So that is what we say. These are the conditions for point to lie either on, inside, or outside the circle. Now I can take an example. I cannot take an example. Example 4. Example 4. Which of the points A 2 5 comma B 1 minus 3 and C 1 0 lie outside or inside the circle, inside the circle x square plus y square minus 3x plus 2y is equals to 12. Question mark. So now, that is example 4. I read the question once again. Which of the points A 2 5, B 1 minus 3 and C 1 0 lie outside or inside the circle x square plus y square minus 3x plus 2y is equals to 12? Solution. Now I can write this in, that is rewriting. What we do is to rewrite this given equation in general form or standard form. Rewriting the given equation in general form. I have x squared plus y squared minus 3x plus 2y minus 12 is equals to 0. So I can now say again this equation, this is the equation in this general form. Now it means since it's a function of two variables, and what are the two variables? X and y. So I can say let f of x comma x, let f of or I can say this implies that f of x comma y is equals to x squared plus y squared minus 3x plus 2y minus 12. So meaning that f of xy is equal to the given equation. So I can do that. Now for point A now, I want to test whether point A lies outside the circle or inside the circle. So for point A, I have my x for point A in this case, that is for point A, coordinates 2 5. So my x for point A is 2, y for point A is 5. So I can now write that f of 2, 5 is equals to 2 square plus 5 square minus 3 into 2 plus 2 into 2 into what? 5 minus 12 minus 12. Therefore, f of 2, 5, f of 2, 5 is equals to 4, is equals to 4 plus 25 minus 6 minus 6 plus 10 plus 10 minus 12. So this is equal to 4 plus 25 is 29. That is 29 minus, so minus 6 plus 10 is plus 4. Plus 4 minus 12 is minus 8. This is minus 8, which is 21. So, and 21 is positive. Since f of 2, f of 2, 5 is greater than 0, then we conclude that point 825 lies outside the given circle. That is the conclusion. Because 21 is positive. 21 is positive, meaning that 21 is greater than 0. So, and that is the condition for a point to lie outside. Then for point B now, what are the coordinates of point B? Coordinates of point B are 1 minus 3. 1 minus 3. So I'm going to have f of 1, comma, minus 3 is equals to 1 square plus minus 3 square minus 3 into 1 plus 2 into minus 3, 2 into minus 3, 1 plus 9 minus 3 minus 6 minus 12. We don't have to waste time. This figure is less than 0. So this is less than 0. Don't waste time. Since f of 1 minus 3 is less than 0, then point B 1 minus 3 lies inside the given circle. Inside the given circle. That's the conclusion. Then point C. For point C. And what are the coordinates of this point C? Point C 1, 0. 1, 0. F of 1, 0 is equals to 1 square plus 0 square minus 3 into 1 plus 2 into 0 minus 12. So this is equals to 1 plus 0 minus 3 plus 0 minus 12. Again, don't lose time. This is less than 0. So, again, therefore, point C lies inside the given circle. I'm done. So now, in conclusion, hence
hence point A 25 lies outside the given circle, while points B and C lie inside the circle. I'm done.